Alright, welcome back. Now, this is Maths Explain Video tutorials, and don't forget to be there for you. Alright, and our motto is to reach the world with the beauty of mathematics. Or our mission is to reach the world with the beauty of mathematics. Alright, so here we are, double angle identities. Double angle identities. Now, a common error for a mathematician is for you to think that cos 2a is the same as 2 cos a. Please, cos 2a is not the same as cos 2 cos a. And for that matter, we need to do research, and that is what we call double angle. So we are going to learn something about this, and trust me, it's going to be interesting. Very good. So we start. Now, when A is equal to B in the identities for the sum of two angles, that is, when we have A plus B or A minus B for sum of two angles, these identities are called the double angle. What we are saying is that if we let A to be equal to B, that means we are going to have A plus B, and that is 2A. And this is what we call double angle identity. For example, let's look at to derive an expression for cos 2A. Let's see how we are going to derive an expression for cos 2A. Alright, let's see how we are going to derive an expression for cos 2A. Very good. Since we said that we are going to let A to be equal to B, that means that if you have cos A plus B, it's going to be the same as cos A plus A. And it's going to give you cos 2A. Very good. Now, don't also forget that cos A plus B is going to be equal to cos A cos B minus sin A sin B. Very good. Sin A sin B. Therefore, since we are saying that we are going to put A to be equal to B, wherever you see A, wherever you see B, put A there. And that's going to give you cos, therefore cos A plus B is going to be cos A minus sin A sin A. And this is going to give you cos 2A, which is equal to this and this, you get cos square A minus sin square A. Very good. So this becomes our first identity for a double angle. Our first identity for a double angle. Alright, so don't forget that two other useful forms of this identity can be obtained by substituting either cos square A to be equal to 1 minus sin square A, or sin square A equal to 1 minus cos square A into this expression. And let's see what that is going to be. Please don't forget, this is coming from a Pythagorean identity, cos square A plus sin square A. That will be giving you 1. So this is coming from there. So if you are saying that this is equal to this, then we can replace cos square A by this or sin square A by this. So this double angle of cos 2A, we can get 3 expressions for it. So let's look at that. Oh, space. Very good. So we can also get cos 2A to be equal to, you know that we are going to put, let me clean it so that I can get space. Very good. So now, cos 2A is equal to cos square A minus sin square A. Now, when we put cos square A to be equal to 1 minus sin square A, we are going to get cos 2A to be equal to 1 minus sin square A minus sin square A. Very good. And you can see that we are going to get the expression of the double angle cos 2A to be in terms of sine. And that is cos 2A. Oh, I'm too much excited today. Cos 2A to be equal to 1 minus 2 sin square A. Very good. Wow. Beautiful. Beautiful. How we can see that? Very good. Do the other one for your own. So this one is the equation 1. This is the equation 2. So this is the second identity for double angle. Let's go for the third identity for double angle. That is when you put sin square A to be equal to 1 minus cos square A. We are going to get that one. We are going to get an expression of the double angle to be in terms of cos. Very good. And that is going to give you cos. What is that? Cos 2A equals to 1 minus cos square A. That is that. By replacing, sorry. So by substitution, cos square A minus, now instead of writing sin square A, we are going to write, bring the bracket because the negative will affect the inside. Cos square A. Very good. And this is going to give you cos square A plus cos square A. Very good. And this is going to give you cos 2A to be equal to 2 cos square A minus 1. And this is going to be equation 3. So we have equation 1, which came by using the sum of cosine, which is by replacing B by A, which is cos A plus A. When you express, you are going to get this. Very good. And after that, from the Pythagorean identity, that is cos square A plus sin square A will be equal to 1. When you make cos square A the subject to replace here, you are going to get your second identity. And you make sin square A to replace what we have here, you are going to get your third identity. So for double angles, we have 3 formulas here. Very good. For only cos 2A. For only cos 2A. Alright, so let's move on. We can also move on to find sin 2A with the identity. Now, if cos 2A came by the identity cos A plus B, therefore, we can also get sine of a double angle by taking it from, sine A plus B. Then we put A to equal to B. So we get sine A plus A. How we can see that? Very good. And it's going to give you sine A sine. Now instead of sine B, write sine A. Sine A. Then the sign don't change. Cos A, cos A. How we can see that? Very good. And oh, sorry. sorry. How we can see that? There is supposed to be sine A cos A plus cos A sine A. So instead of sine A cos B, cos B cos A sine B is now replaced by A. Alright. Very good. So with this, what are we going to get? And we are going to get sine 2A to be equal to, you can see what we have here is the same as what we have here. So this is 2 sine A cos A, equation 1. So for sine of a double angle sine 2A, this will be the double angle for that. Very good. This is going to be the double angle for that. Can you get any other again? That is all. For cos, you get 3 identities for double angle. For sine, you get 1. And that is only this. Let's move on to use the identity for. Okay, what about if you want to get the double angle for tan? What will you go for? That is tan. You go for tan A plus B. Very good. So, I'd like to bring that part. Layer out of the quick. Alright. So for tan A plus B, we put, or we know that tan A plus B is equal to tan A plus tan B, all this over 1 minus tan A tan B. Very good. So when you put A to be equal to B, you get tan A plus B, tan A plus A to be equal to tan A plus tan A over 1 minus tan A tan A. So this is going to give you 2 tan A over 1 minus tan square A. Nice! So that is the double angle for tan 2A. That's the double angle for tan 2A. So you see, it's not by chewing, it's not by chewing formulas, okay? It's about understanding it so that even if you are in the exam form and you need the double angle for tan 2A and you have forgotten it, you can just quote, you can just go for the formula for tan A plus B, then replace the B in it by A, and you get your double angle for tan 2A. Very good, I love it. Let's look at, so what is next? That is all. So for double identities, for double angle identities, we have cos 2A. We have cos 2A, whereby we have 3 expressions for A, that is cos square A minus sin square A, and the other is 1 minus 2 sin square A, and the other is 2 cos square A minus 1. Very good. That is for the 3 double angle for cos. Then you move on to sine. For sine, we have only one. That is sine 2A, and that is 2 sine A cos A. Sorry, yeah, 2 sine A cos A. And the last one is tan 2A, and that is 2 tan A over 1 minus tan square A. Please, it will be very helpful. It will be very helpful for you to get all these formulas up there, alright? So that it will help you. And one thing about mathematics is that once you know how to derive it, getting it up there is not going to be a stress for you. Very good. So let's move on to solve some questions relating to double angle identity. All right. Given cos, given given that cos theta is equal to 3 over 5 and sin theta is less than 3. Find sine 2 theta cos 2 theta and tan 2 theta and tan 2 theta. Very good solution. So that is that. Let's go for it quickly. So in the question, sorry. In the question, we have cos theta to be equal to 3 over 5. And we are saying that sin theta will be less than 0. That means that sin theta, the value for sin theta is going to be a negative value. Okay, so the first thing to do is to indicate the quadrant, or is to know the quadrant you are working with. Very good. So let's go for that. Now, all students take calculus. Cos is positive. Oh, that means that 4 quadrants. But not only that, we are saying that sine is also a negative value, or sine is less than 0. So for sine to be less than 0, that means that it will be 0 because sine is negative on the 4th quadrant. Very good. So the quadrant we are working with, so we are using quadrant 4. After identifying them, then let's move on. Let's go and find sine 2a. We know that sine 2a is equal to 2 sine a cos a. Very good. But you can see that we don't know that of, we know that of cos theta, but we don't know that of, so we are using theta, not a. We know that of cos, but we don't know that of sine, so we can go for it. From Pythagorean identity, you can also go by sketching, alright? You know it's in the form quadrant, you can go and sketch and look for sine. Another way to go by it is that we know that let me go and do it here. You know that sine square theta plus cos square theta is equal to 1. So cos square theta will be equal to 1 minus sine square theta. So cos square theta is equal to the square root. Cos theta is equal to the square root of 1 minus sine square theta. Very good. And we know that, we are rather looking for sine. Alright. So no problem, just replace template. We are rather looking for sine. So sine square theta will be equal to 1 minus cos square theta. So sine theta will be equal to the square root of 1 minus cos square theta. Very good. So we know that cos is 3 over 5 squared. Right. And when you do that, you are going to get, now don't forget, the moment you take a square root, bring plus or minus, plus or minus. So sin theta is going to be 4 over 5. Now, is it going to be plus or minus? On the fourth quadrant, we are working in the fourth quadrant. So on the fourth quadrant, sign is negative, but cos is positive. So let's move on. Quickly, 2 times negative 4 over 5 times cos, which is 3 over 5. So we end up by getting. Alright, you can pause the video and continue the rest on your own. So for sine 2 theta, we are going to end up by getting negative 24 over 5. Negative 24 over 25. Negative 24 over 25. Very good. So we can now move on to find cos 2 theta. Okay, we can go for cos 2 theta. Since sin theta is known, all the formulas will work. We have 10 formulas to work. But let's go for 1 minus sine squared theta. Okay, when you go for 1 minus sine squared theta, you can get it. If you go for, 1 minus 2 sine squared theta, you can get it. If you go for 2 cos squared theta minus 1, you can get it. And if you go for cos squared theta plus sine squared theta, cos squared theta minus sine squared theta, you can get it. Let me tell you something about cos squared theta minus sine squared theta equals 1. Please, here is different from this. From the one coming from Pythagorean theorem. Okay. This is coming from Pythagorean theorem, which is equal to 1. But this is coming from double angle of cos 2a. And here is minus, here is plus. So please, when you are dealing with such cases, be careful. Alright. So with this, you can get 1, 2 times. Sine is negative 4 over 5. Right, very good. And you square this, and the final answer is going to give you negative 7 over 25. You end up by getting negative 7 over 25. Very good. So that's what we are going to get for that. Let's go for the last one. The last part is tan. Tan 2 theta is equal to 2 tan theta over 1 minus tan squared theta. So with this, we get, first of all, we need to go for tan. Okay, first of all, we need to go for tan. So tan theta is equal to sin theta over cos theta. And we know that sin theta is negative 4 over 5. All this over cos theta, which is 3 over 5. 3 over 5. Very good. So with this, we are going to get negative 4 over 3. Negative 4 over 3 here. You're going to get negative 4 over 3 for tan theta here. So by substitution, tan 2 theta is going to be 2 negative 4 over 3. All this over 1 minus tan all squared. What is tan? Negative 4 over 3. And we finally end up by getting 24 over 7. We finally end up by getting 24 over 7. Very good. Thank you for that. That is all I have for you in this video. Oh, let me check. Oh, last one. Hey, not even the last. Let's move on. It's good to solve more questions. It's good to solve more questions. Very good. So we are done with this. Let me clean it. Make sure you have all the formulas for double angles, for sum and difference, for the fundamental identities and all that. Make sure you have all of that in mind. Very good. So let's look at how to verify a double angle identity. How to verify a double angle identity. So you can be given to verify that example 2. Verify that cos S cos cot S sin 2S is equal to 1 plus cos 2S. Very good. So, given this to verify, like what we have been doing earlier on in our previous videos, what we do is that we pick the one which is more complicated, the part which is more complicated, then we simplify to get the other side. Very good. So, alright, so we look at how to verify these double angles. So let's look at the first one. Now this is similar to the one that we did in verifying trigonometric identities, alright? In fact, know all your fundamental identities and also all your double angle identities, and you'll be able to verify it. So we pick whether the left hand side or the right hand side, the one that is what's complicated. So for the first question, we have cos S sin 2S is equal to 1 plus cos 2S. So we pick from the left hand side, which is cos S sin 2S. We know that cos S is cos S over sin S, which is multiplying sin 2S. This is double angle. And it is the same as 2 sin S cos S. So you can see this sin S will cancel this sin S. And we end up by getting cos. Now this is cos S and cos S. That's going to give you cos square X. So we get 2 times cos square X. Now, this is our hope, or this is where we want to arrive. Very good. So with this, what is going to help us? Now, from a double angle identities, we know that cos 2S is going to be, we are going to pick the one which is in terms of cos X, and that is 1, that is 2 cos square S minus 1. And you can see, when you make 2 cos square S the subject, it will be the same as this. So we get 2 cos square S equal to 1 plus cos 2S. And that is exactly the same as what we have on the right hand side. So therefore, 1 plus cos 2x is the same as the one we have on the right hand side. So we are established in proving that. Very good. Let's go and try on another one, which is the question 2. The question 2 also, we have tan S plus cos S to be the complicated side. So let's pick that complicated side. This is the same as sin S cos S. Plus this will give you cos S tan S. Very good. Now, we know that here the LCM here, sin. The LCM here is going to give you sine s cos s. Alright? So this cancel this. Sorry, this cancel this, then this multiply this. So we get sine square s plus here, this cancel this multiply this. So that gives cos square s. Now we know that the numerator only, but the numerator only, sine square s plus cos square s is equal to 1. So here is the same as 1 over sine s cos s. Know that it is the same as sine s cos s. How beautiful. But where do we want to? The hope of, let me see, our hope is to get this 2 cosec 2s. Oh. But don't forget that what we have here, don't forget that 2 cosec 2s, this is the same as 2 multiplying 1 over sine 2s. Very good. So we need to get a double angle. We need to get very good, very good, very good. How we can see that? How we can see that? We need to get a double angle of sine on the denominator. But we know that, watch. But we know that 2 sine s cos s is equal to sine 2s. Very good. But in the case that we don't have that 2 here, watch. So for us to get that 2 here, we bring the 2 here. Alright. Now, when you bring it, what you will do it. If not, it will change everything. So we multiply 1 over sine s cos s by 2 over 2, which is the same as multiplying it by 1. And that is not going to change anything. Very good. So here, we get 2 over 2 sine s cos s. Nice. And we can say that this is 2 times 1 over the whole of this will give you sine 2s. Alright? And that is exactly what is equal to this. So this is exactly 2 cosec 2 cosecant cosec 2s. Wow. And that is exactly what we have proved. I love it. Nice. So let me give you some to go and try your hands on it. Very good. You can go and try on, let me give you only one. Or you want more than one. I trust you. You will do it. I trust you will do it, yeah. Very good. Let me give you this. Try this. So go and try the third one. And that is sine s plus cos s squared, which is equal to sine 2s plus 1. Try on that for me. Very good. Try on that for me. I think that's all. Very good. So that is that. Let's move to the next question. Okay, so let's add up. Question 3, or example 3. Simplify each expression. Simplify each expression. Alright, so looking at this question, let's try on the first one, the A. We have cos squared 7s minus sine squared 7s to simplify. But don't forget that. Sine square or cos square s minus sine square s is equal to cos 2x. Now, you need to understand what this means. Alright, very good. Now what this means is that look at the argument. The argument there is x, the argument here is x. So we are saying that if you have something in a form cos squared minus sine squared, the argument, twice of the argument is cos 2x. So we are saying that the result of this will give you cos of 2 times the argument. 2 times the argument. So here the argument is fx. That's why we have here to be 2 times x. Very good. So if you have cos squared 7x minus sine squared 7x, all that we are interested in is that it is cos squared minus 7 squared, not plus, but rather minus 7 squared, sine squared. And the argument, they are the same. Here is 7x, here is 7x. So the result of this, or the simplified form of this, is going to be cos 2 multiplying the argument, cos 2 multiplying the argument. That was right. So the simplification of this question will be 14x, and that is all. Alright, that is it. Let's go for that. Oh, how are we going to try on this? How are we going to try on this? It's just simple. Alright, very good. Let's look at it. Let me do that here. B. So, to have sine 15 cos 15. Very good. So, what this also means is that we know that sine s cos s is equal to sine 2s. Oh, sorry. Is 2 sine s cos s is equal to sine 2s. Very good. So, having this, I think I need space. Let me clear off this part and clear off this part. Very good. So now you can see that for us to get the same as what we have here, we need to do something. You know that the argument representing s here is 15. Is 15. So here, 2 sine s cos s is equal to sine 2s. But what we want to relate to, there is nothing like 2 here. So let's multiply this by half. Let's multiply this by half. So here we get sine s cos s is equal to half sine 2s. Very good. Very good. So we can now relate this to this. And the argument representing s here is 15. So you put s to be, oh I love this, 2s equals 15, and this will be sine 15 cos 15 to be equal to half sine 2 times 15, and the result is half sine 30 degrees. That is all. You're going to get half sine 30 degrees. And sine 30 degrees is going to give you half. Therefore, you end up by getting half times half, which is 1 over 4. So the final answer will be 1 over 4. Alright, so you can see the identities involving larger multiple of the variables can be derived by repeated use of the double angle identities and other identities. Very good. So let's look at how to derive multiple angle identity. How to derive multiple angle identity for triple angles. For triple angles. Alright. You have double angle to be 2, let's say 2A. So the triple angle will be 3A. That's how it's going to be. So we are going to do it. We are going to derive it in a question form. That is example 4. Example 4, write sine in terms of sine s. We have to write sine 3s in terms of sine s. Very good. Let's move on. So, all that we know for now is sum and difference, identities, double angles, and all that. Very good. So let's look at what we can do here. So for sine 3s, we can split this argument 3s to be sine 2s plus s. And this is the same as this. Very good. But we know that sine 2s plus s is in the form a plus b. Alright, that is sum of sine identity. So let's go for that. It will be sine 2s cos s. So we can see that here is plus, so the sign don't change. Then cos 2s sine s. Very good. Now, having this, you can see that we have double angle inside of it. Very good. But we are writing sine 3s in terms of sine s. Therefore, here we have only one identity for sine 2s, and that is 2 sine s cos s times this. 2 times cos s plus this a double angle. Now we have three identity for cos 2s, or three formula for cos 2s, but we want the one which is in terms of sine, and that is 2 no, and that is as I said, it must be okay. 1 minus 2 sine s, 1 minus 2 sine square s, multiplying by sine s. So here we get 2 sine s cos square s plus sine s minus 2 sine to the power 3 s. Very good. So we are writing to get it in terms of sine s, then we end there. So what this is going to give us is, since we are writing it in terms of sine s, and here we are having cos in it, so we have to undo that. So here, the identity that we can replace it by cos square is that we know that from Pythagorean identity, cos square s is equal to 1 minus sine square s. So by substitution, alright, so that's what we get for sine, for the substitution. So this time is we get 2 sine s minus 2 sine square s sine cube, okay, plus sine s minus 2 sine to the power 3s. Very good. Now, this and this, we get 3. We get 3 sine s minus, very good, 3 sine s, and we get 4. So now this and this, we're going to get minus 4 sine to the power 3s. And that is sine 3s. Triple angle. So as we have multiple angles, we also have triple. Well, as we have double angle, we also have triple angle. So this will be deriving a multiple angle identity. So this is going to be multiple angle identity. Please, even if you want to write sine 4x, you can still go for it. It's all about your understanding because this is going to be the same as sine 2x plus 2x or 3x plus x. It can be that. Then you go your way. Very good. So that is all. That is all. You can see that our last example applying the multiple angle identity to answer a question. Very good. So that's all. In our next video, we are going to look at. Now we are done with sum and difference. So we move to product to sum and sum to product identities. Until then, know that you are loved. For any support, you can email to me. You can email me for us to talk. And you know my email account as frederickchampon88@gmail.com. Alright, and you can send all your questions also through there also. Thank you. See you in the next video.